Now remember with trig substitution says this type of integral you have right here. This is one of the identities of trig substitution right here. There's also a variety for if that's a minus or if the a and the s's are switched. There's several of those. We can go over those again, but this is the classic one right here. Now in this case, I notice I have a 2 here, and yet this is a squared. So that means a squared is equal to 2 right here. And if that's true, that means my a is just equal to the square root of 2. So when evaluating this integral and plugging it into here, plugging in for my a using the square root of 2, that means this integral right here is equal to 1 over the square root of 2 times the inverse tangent of s over the square root of 2. I'm not going to bother writing my constant just yet because I'm going to have to add other things. So now I've solved for this integral finally, but I still have it in terms of s, and I need to get all the way back to my original variable, which is x. Well, I defined s in terms of u, so first let's switch this back to terms of u, which is 1 over the square root of 2 times the inverse tangent of u plus 1 over u, all divided by the square root of 2. And now let's convert this back into terms of x. Remember, u is equal to the square root of tangent x, so this becomes 1 over square root of 2 times the inverse tangent of square root tangent x plus 1 over square root tangent of x, all divided by the square root of 2. So this first integral right here, this is our solution right here. So this is the first half of our solution right here. So now we need to take a look at this one right here.